Hi, welcome to this session. In this session I'm going to talk about the CreepSop. Now the Creep is a special tool that allows you to deform geometry by using a patch surface or a NURB surface. So let's have a look what this tool is by pressing tab and typing creep. Here you can find it, and there are a few things which I'm going to explain on how this whole thing works. So we have the geometry which is going to be used to be deformed by the patch, and then over here the geometry which is the patch itself being used to deform the geometry. So first thing that we're going to create is we're going to create a grid which is going to be our patch deformed surface. So by default you will have a grid something like this, and the thing that we're gonna do is we're gonna make the size unit size. We're gonna make it 1 by 1 to start with, so that it nicely fits over here within the grid. And the other thing we're gonna do is we're gonna change it into NURBS, because you really need to have NURBS in order for this to work. The reason why you need NURBS is because the creep tool is using the UV properties of the surface in order to creep something over it. Okay, so now the next step. What you should do is you should install one digital asset which is provided, and in that digital asset you will find the axis digital asset. So when you've installed it, you can use it over here, and this creates you just a asset, an axis with all the colors. And what you can do is you can switch this one to polygon. The reason why you should switch it to polygon is because this allows you to deform the axis also, so that you can see what some of the effects are. So let's have a look. If we're going to connect over here the axis into the CreepSop, and so this is the first result what you're gonna get. Now there are a few things which are perhaps a little bit strange or annoying. One, first of all, is that since most of the time you're getting used to creating like a surface like flat on the ground, something like that, in which you have the y-axis as a top value, it might be strange that it is using the z-axis as an up direction. So the normals which you see over here are going to be the z-axis of the object. So if you're gonna see over here, we have the z-axis over here, and you look at the creep, you will see the z-axis is pointing upwards. So that's one part, and that's fine. But the other thing you will notice as well is that we have over here, if we look at it perhaps from this direction, it might be easier to see it, perhaps like this. If we see if the z-axis is pointing upwards, then we have the y on, let's say, the right side of the x-axis. If we look over here at the creep, we have the y at the left side. So here's some kind of an inversion. So in order to fix this, one of the things you should do already is to change one of the scaling values. And what you can do is you can negate, for example, the y scale value, and this at least will make it a shape which is at least correct and not mirrored or not reflected in one way or another. But as you can see, it's not sitting right in the middle, it's not really centered, and we see some nasty deformations. So all these are things that we will have to address one way or another. But this is the first step. So first make sure that you have already a proper axis again. The other thing is, what I usually tend to do is I like to keep it, like I said, the orientation of my object as I see it over here, so that when I'm using a grid surface flat like it is over here, that the model I'm going to have is going to be represented in exactly the same way as I see it right over here. So one of the things that I can do is I can rotate around the x-axis, and now I don't know by heart, but I think it's 90 degrees, or it must be minus 90 degrees. So it is indeed, as I said, second one, 90 degrees. And so right now we have at least an axis which has proper orientation and which has also a proper scaling. So the y is now upward, x is in the right direction, and the z is in the right direction. So everything follows as we see it right over here. So these are already very few important setups you have to deal with. Okay, so what's happening in fact with everything we see right over here? Because what we see is we have our axis right in this corner, and it's being pushed completely to the side. We see some parts are flattened of the geometry. We also see some stretching. Now we're not going to bother about the stretching and the deformation what we see right now, but what we're going to look at is how this flattening is occurring and why it's being offset into this direction. The reason is the following. The creep is making a direct mapping of the values we have in world coordinate space and maps it directly into UV space of the shape that we have right over here. So all the vertices which are in a negative x value or a negative c value are being clipped because the UV values start from 0. So the negative values are just being squashed to the value of 0. So that's why we see this flattening occurring over here. So this also means that in this case those values go to a value of 1, so they match perfectly right over here the u and the v values of 1. So this also means that if I'm going to make, for example, the size of this arrow twice as long, let's say this long, let's say twice as long, as we can see it right over here, then we're gonna see in a creep that's going to be clipped just until this value. Okay, so that's how this works. So in order to make sure that a shape is always fitting completely on the grid, you should make sure that this shape is always being normalized. So that's also again a important reason why you should use normalization. So let's put this back to a value of 1, and we're going to normalize this shape, normalizing in such a way that it's going to still be in the center, but that its values are going to sit right within the appropriate levels. So how can we do that? Do that by the following. We transform the object, and we're going to translate it by a half in the x direction and a half in the z direction. So that's one part of it. Now we see these parts are going out of range, so if we see the creeping, now the object is right in the center, exactly where we want it to be, and we have it right over here, so that we see it's still too long, and so therefore we see this clipping occurring again, and so it's getting over the range of 1, over here. So what we can do as well is we can scale the whole thing by 1 so it fits nicely within this whole range, and now we see everything fitting right within this creep. Okay, now having objects being normalized this way is quite annoying, because now we have everything in a positive in the positive values, and what we tend to do, or what we used to do, is to make sure that everything fits nicely in here. So that's not what we're gonna do. We're not going to translate the object. We're gonna make sure that it's going to be fixed over here in the creep. So this is something you can do also over here. We can translate a half in the U direction, and we can translate a half in the V direction. We're not going to touch over here the W direction, because the W direction is going to be up or down, as you can see. So keep in mind that the translations, etc., are now not matching anymore the alignment that we see right over here, and the reason is exactly because we've done this rotation before, in order to make sure that this representation matches what we see over here. Okay, so now we do have like a great or a good initial setup that we can use at all times if we have like normalized shapes. So first thing that I'm gonna do right now is we're gonna make sure that I'm going to save this as a preset, and I'm not going to save it as a normal preset, but I'm gonna save it as a permanent default. So whenever I'm going to use the creep right now, by default it's gonna get all these values. So now it's very easy to just connect with a normalized shape, and it's just doing everything I'm expecting it to do. Okay, now if we see over here our shape and we see the result over here, we see there's a lot of deformation going on over here, and the reason is because how this surface is being represented as a NURBS surface. Now there are several things you can do about this. First of all, you can change this into a UV order of 2. If you do that, you get like linear NURBS, and this is going to make sure that everything is going to match up perfectly. So as you can see, the original and the creeped version are now matching up perfectly. They're exactly the same. So if I'm going to transform now, if I'm going to apply, for example, let's say a twist on the whole surface, and let's see, am I going to twist? I'm going to twist it in a strong way this direction, and let's see, z-axis doesn't matter really here, and it doesn't show too strongly, of course, this way. Let's see if we can apply a bend function, and the bend function I'm going to do z-axis. I'm going to use an X with a Z-axis, no, a Y with a Z-axis. Okay, this is looking better. So if we see now over here, we see how the creep tool is deforming our surface. Now that's all very nice, but there are some issues. Now because the grid is a linear NURBS, what we created now, we see also that the interpolation is very linear. It doesn't give us a very nice interpolation. Let me just show you what it will be if we change the U and the V order to level of 4. We see the deformation is much smoother, but again we have like this squash and stretching. So how can we solve these issues? Now, especially when making the grid, there are a few things that you can do about this. First of all, we can change over here the endpoint interpolation and endpoint interpolation in U and V. So as you can see over here, we see those palms, they're not being exactly on the right spot. If you add these, everything is on the right spot. You just see that the grid is becoming smaller, and that you have like this whole new set of extra control points. If you do a twist on this surface and you do a creep, then you not only get like proper interpolation, but you also don't get like the deformation. So if I'm going to disable the twist over here, we're gonna see everything fits nicely. You say it doesn't. That's correct. We see it a little bit transformed as an egg. Now the reason is that, as we can see it over here, the primitive area is smaller than unit size. So in fact, to make it like really correct, you should transform it and make it so that it is scaling up perfectly with what we have over here. Something like this. If you would see the creep, then it's all normalized. So those are some methods or ways how you can solve this. Now suppose you don't have the ability to create a NURB surface this way, and you're stuck with something like this. So what should we do then? How can we solve it? Well, like I've shown in a previous video, over here you can also use basis in order to fix it a little bit. So let's go back over here, remove the twist, and see what the result is going to be like. I'm going to switch this one off as well, and let's try and fix it as much as possible using the basic. So we can use approximate arc length in both directions, and this will solve it or make it just a little bit closer to the shape we have. As you can see, it's not perfect, but it's already way better than what we have in the first place. So chord length just gives you a little bit better result even. But uniform, centripetal, these are other things. So yeah, that's most likely the best result. Adding more subdivisions, of course, is going to help as well, so that the deformation is going to be shifted more towards the edges. So these are all kinds of things one could try and do to solve these issues. Great. Now the cool thing about this CreepSop is that you can use it, of course, in combination with, let's say, with polygons. So if you have, let's say, a polygon, let's say take a box, oops, wrong note. If you take a box and let's say that we do a point jitter on that box, then we have a surface which is quite deformed. And let me just get one polygon from that. Delete non-selected. Well, let's say something like this. So the thing what you can do is you can convert, for example, a polygon to a NURB surface. Now once this has been converted, you can use it also over here in the creep, and as you can see, the whole thing gets properly deformed following exactly that shape. So you can find all kinds of methods or ways how to do that, for example, for each one of those box elements, etc. So this concludes what I can tell you about the CreepSop. So keep in mind that you need to have like a good understanding on how to use this setup. You can also apply an initialize. That's something I forgot to tell you. An initialize will allow you to have a shape which is not fitting those proportions, to make it so that it automatically fits into the whole shape over here. But by setting it up this way and normalizing the shape, you're sure that you can do it in a procedural way, because with the initialize you can't do it procedurally. And over here, these are things you are probably able to figure out yourself right now. So you can set up some attributes, you can get some attributes from surfaces, etc. So try and experiment with that. And so I hope to see some very nice results of you using the CreepSop, because you can use it in many ways.